Welcome to the House of Maths. Today I'm going to be looking at equations of straight lines, but I'm only going to be looking at the basics today, nothing particularly difficult. So these are the three things that I intend to look at: just vertical and horizontal lines, the main diagonals, and lines that go through the origin, what they're going to look like as equations. So let's start with vertical and horizontal lines. So here I've got my coordinate grid. This part here is the y-axis, this part here is the x-axis. Now we refer to quadrants on our coordinate axis. This quadrant here we refer to as the first quadrant. This is the second, this is the third, and this is the fourth. Okay, so these lines can appear in either quadrant, in any of the quadrants, or they can go through more than one quadrant. So let's first of all look at some vertical lines. Okay, so if I put a vertical line on here, like so, you can see that it passes through where x is 2. Now, anywhere along that line, if I go here, x is still 2. If I go down here, x is still 2. If I go there, it's 2. Anywhere on that line, x equals 2. So the equation of that line is just x equals 2. If I come across onto the negative side and just go down here, draw a straight line there, anywhere on that line, x is minus 3. So wherever I put my pen, x is still minus 3. So that line is x equals minus 3. So let's have a look at horizontal. I'll just rub these off first. Okay, so if I draw a horizontal line here, okay, you can see on this one we are crossing through where y equals 4. And again, anywhere along that line, y equals 4. So that line is described as the y equals 4 line. If I come down here, that is minus 2. Close enough. So this line here, anywhere along this line, y, anywhere I put a point, that line there, that point there, sorry, is minus 2 in the y direction. Over here, it's minus 2 in the y direction. So that line is y equals minus 2. So you can get any straight line that is going either horizontally or vertically in the same manner. Doesn't matter whether it's this one here, if it's exactly midway between, it's on the x side this time, so this one is x equals minus 1.5. So you can describe any vertical or horizontal line in that manner. Let's just remove those lines. Okay. The second point, the main diagonals. Now the main diagonals basically mean 45 degrees through the origin, like so. Okay, passes exactly through the origin and it's at 45 degrees. So this line is going to be the y equals x line. Now why is it y equals x? If you take any point on the line, say I take this point here, the coordinates of that point are 1 along, 1 up. Okay, if I take a point here, that one is 2 along and 2 up. So the x value and the y value are both the same. And it's the same over here as well. If I plot that point, that's going to be -1, -1. And if I come down here and plot that one, that's going to be -4, -4. So the x value and the y value are exactly the same. So that is one of the main diagonals. The other one is going in this direction here. Okay, and this one is the y equals -x line. Okay, so again, if I take a point here, lined up with these two, so the x direction, -2, 2. So y is 2 and x is -2. If I take that point up there, I'm going to get -4, 4. Okay, so that is the y equals -x. If I go over here, same thing, I've got 2 -2. Okay, so we've got x and y there, and equals, put a comma. Okay, so how does that work there then? That looks a little bit different, doesn't it? So we've got y equals, so the y is -2 and the x is just 2. So the signs appear to be the other way around now, don't they? But that's okay. So here we would have, if you like, -y equals x, which is pretty much the same thing. So that's okay. But we refer to it as the y equals -x line. So that's what you get with the main diagonals. That one there, y equals x. This one here, y equals -x, or you could do -x equals, sorry, -y equals x. Both okay. Okay, and the last one is lines through the origin. Well, those two that we've just looked at, the main diagonals pass through the origin at exactly 45 degrees. But what happens if they don't pass through at 45 degrees? So if I have a line that goes through like that, it's clearly not at 45 degrees. So it's clearly not going to be y equals x. So you can't say y equals x for this one. That doesn't work. But what you can say is that there is some relationship between y and x. We've got a straight line going in this direction. So there is a connection between y and x. As x increases, y is also increasing. But x is increasing a bit more quickly than y is increasing. So it's not a kind of 50-50 relationship like it was when y equals x. So we describe this one as y equals some constant. We usually refer to it as an a. Y equals ax, where a is basically telling us something about the relationship between x and y. So it's telling us something about how quickly one of the variables is increasing in relation to the other one. Now what you usually get, if you get a very steep line, like for example this one I'm putting in here, this line here, then we're going to get a is going to be large, and on this one, if it's below 45 degrees, a is going to be small. So it tells us something about the steepness of that line. This one's fairly flat line, so A is going to be small, less than 1. This one's a very steep one, so A is large, and it's going to be telling us something about how steep it is, much steeper. Now, what happens if the line goes in the other direction? What happens if we have one that's coming, say, down in that direction? Well, it's still this form, but we're going to have a negative in there, because the easiest way to think about it is going downhill. This one's going uphill, this one's going uphill, so A is going to be positive. This one's going downhill, so it's going to be negative. So we can refer to it as a negative gradient is the word that we tend to use. So gradient is telling us about how steep a particular line is. So this is going to have quite a big negative number because it's a steep negative gradient. This one here, okay, it's not very straight, but it's a straight line. So this one is going to have, it's going to be, again, it's a negative gradient. You can see that because it's going downhill, but the value of A is going to be smaller, probably less than 1, because it's less than 45 degrees. So long as these scales are exactly the same, which they are on my diagram. So if it's less than 45 degrees, it's going to be less than 1. So that's through the origin. What we'll look at next time is when the lines don't pass through the origin, what happens then. But if you like this one, don't forget to hit the like button and subscribe if you want to. See you soon.